Processing two-dimensional arrays. So pretty much initialize arrays. We look at that, right? Declare them and give the values to it. Either initialize it directly or through the input. So we can use graphic user interface to do the input. We can use scanner to read in the input from keyboard. So in this case, GUI would be better because it's easier to just input everything at once and do submit, right? To read in all inputs when your array size is large. You can print arrays using loops, right? So this one want to sum the elements, all the elements. You can add all the data using loop. You can do by columns and see which one is the largest sum, which row, and you can find the smallest index and shuffling them. So let's see how we do that. So this is how we initialize arrays using loops, right? We can prompt the users using scanners and using iterations nested to prompt and store data. But when you ask the user, you have to prompt with the specifying rows, right? And columns. So you can either use random generator, right? Math.random to generate random values to assign to your array. So this one we just look at with input values, right? From the scanner. And to print arrays, we do the same iterations and print, like print line, pretty much just go to a new row. Print all the data in the columns and concatenate with the spaces. To sum, instead of print, you pretty much just do accumulating the values of each to the total. Then you can find the sum. If you want to sum by columns, so pretty much you have to specify. So the first one, before we iterate by row, right, and then columns, then we actually just going to start to iterate by column first, go down with the columns and get into each row and then sum them, right? Instead of iterate diagonally, so we just iterate vertically and then get the sum of the columns. So how do we shuffle? So we pretty much has the two-dimensional arrays again, rows as I, J as columns. We're gonna use math.random, okay, to generate the numbers. So again, math.random is going to return a number between 0.0 until 1.0, excluding 1. So that's why we want to multiply with the length for the row. Then we get to cast it to int because math.random returns double. So after we cast to int, then we get a new ij, pretty much new row location. We try to shuffle, right? And this is happened for the columns. Then whatever data at that ij that we iterated earlier, we put into temp, and we pretty much just take the data at the new ij that we call I1 and J1 and put into that location. So it's replacing the data at the first, if we start from 0, 0 index, to the new one randomly generated location. Then we put temp back, so that's just swapping, right? Temp back. So the one from the starting ij go down to the randomly generated ij, and the randomly generated ij just go to the one from original ij. So that's how we shuffle. Now like we said, we can pass this through the parameters, right? And these are the example of the application. So let's look at passing through the parameters first. So we create a method named sum, right? So sum, same, when you declare, this is the two-dimensional array, so in the parameter of the method, it has to have two brackets, right? And this is an array that in the main, so we call get array. So beside passing, we can return a two-dimensional arrays too. So get array is going to return the array that we pretty much just create from entering the values from the user prompt. Two-dimensional arrays 3x4, right? And we already know the code how to enter the values. Use nested loop, return back. So M pretty much has the data from the user input. Now we want to find the sum of the data that we read in from the user. So we pass in this M to the method named sum, which is two-dimensional arrays. And this is pretty much just isolating it. And we look at the code how to sum them, just accumulating into the total and return total. So that's how we write the methods to return two-dimensional arrays and to take the parameters as two-dimensional arrays to calculate for the sum. Now this is for the application student grades. So we have 8 students and we have 10 tests and the grade for each test for each student. So actually this is like number of questions, right? Each student have 10 questions, and these are the answers that student pretty much provide. But this program will grade having the key answer to each questions. Right, this how we can use two-dimensional array to help on this application. Let's take a look. So we initialize the set of the answers for 8 students with 10 questions. So this is multiple choice questions. And we have one dimension array with a key set. Now what we need to do, we pretty much just need to iterate, right, through this two-dimensional arrays. So this is called answers to each row, and we compare if each row equals to the key. So we have arrays to compare to single dimensional array key. So if they are equals, then we pretty much just count the score, correct count, initialize to 0 first and increment them. We have to initialize inside because we're going to count for each student. So it has to be inside the row, right? Then we pretty much just print out the grade of each student when we're done. So that's how we apply the two-dimensional arrays for the grading application. This is another application, finding 2 points nearest to each other. So we have 8 points, and those are the coordinates of each point. And we want to find the nearest point that nearest to each other. So that means we may need to look at the distance formula, right? x2 match x1 and y2 match y1, right? And this is the distance formula. By passing to four points, right? Then we get the shortest distance back. So let's start looking at the beginning. So we prompt the user to enter all the points and the number of points, read in the number of points. And we know since this is going to be x and y, so it's going to be just 2 columns. So that's why we specify as 2. Now start to prompt the user number of points for each point. So it's going to be, the first one is x, 0, and the second is y, which is 1. So we prompt them and read them at the same time, x and y. Now we have the points ready. So this is the 2 points with 2 coordinates, right? X and y, x and y. When you pass that into the shortest distance, shortest distance is the formula like to find the shortest distance, like I told you, x2 minus x1 times. So the square root of x2 minus 1 times x2 minus 1 plus y2 minus 1 times y2 minus 1. It's actually, the formula is x2 minus x1 square plus y2 minus y1 square, and square root of the whole thing. So that's why it's times like that. So we get the distance for the shortest distance when we pass those 2 points in. And we just assume that that's the shortest. So this is the same principle that we find the mean number, right? We just assume that the first point is the shortest, unless we found, right, if the new shortest is when we iterate to each, right, like we did find the mean and then we find the new shortest. But this is the 2-dimensional array, so we're going to iterate with I and j, because x and y is changing, and pass it into the distance to get the new distance. If it happen to be shortest distance happen to be greater than the new distance, then the new distance is the shortest. So this is the same principle when we look at how to find mean. And then we just return the shortest, or print the shortest out, right? The closest 2 points are, because that's the shortest distance, and print the closest 2 points out when we found. And that's how the application works. So another example, we can use the multi-dimensional array in Sudoku question. So what's Sudoku? Sudoku is a game that you have to find the missing number in this square box, small square box. It has to be sequenced from 1 to 9. And also in the row, it has to be sequenced from 1 to 9. Right? Like that. So this is an example. That missing number are 1, 2, 4, 6, 8, 9 for the row, and in the box itself. And also for the columns too. It has to be 1 to 9, so row and columns, and the box. So now, how we gonna write a program to find the answers? This is quite a little bit long program, so